responsible.
Man, my fantasy.
Well, let's see if we get there faster today. I keep working at it. I'm going to figure this thing out. The online people love it. I'm finally figuring out how to get here as quick as possible so they don't have to watch me run back and forth turning on this machine. Praise the Lord. Okay, we're on page 323. Practice test for chapter 5. What's that? Third down at the bottom? Whoa, this is one long practice test. Probably, when you take notes on this practice test, you probably want to put your notes on a piece of paper and then set them aside and then go through the test and take it on your own, then compare your notes to see how well you did. Because I can just tell you, the test on Monday, that when you come back from the break, it's the longest test of any of the tests in this course. And it's the next to the last one, because the next chapter is chapter 6, and then by the time we finish chapter 6, the semester's ended. So, but this will be the longest test you'll be taking. So let's start out with problem number 1. And it's from page 230. Are these, are the underlined items cardinal numbers, ordinal numbers, or identification? And what is A? If it's came in third, where was that? The third place in the race would be cardinal, ordinal, or identification. Ordinal. It's the order in which they came in. So A is ordinal. What's B? Bill's lottery ticket won $2. Cardinal, ordinal, or identification? Cardinal, because cardinal is how many? And then C, Jane's auto license number is 270891. Cardinal, ordinal, or identification? Identification. Everybody follow that? Go back and write some notes from, probably if you have a page that you're taking notes on for this practice test, and then you write down page 230. Then you go back through the text and write down some notes that you're going to bring with you to the exam. Because it's easy to say, oh, I see it now, but just seeing it now won't make it stick with you when you come in here on Monday to take the test. So you'll need some notes, and then you can bring your notes from the practice test. Then you can bring the notes you've taken from the chapter with you when you walk in here to walk through the test that I'm going to give you. And skip problem 2 because it's not going to be on the test. So we go to problem 3 and write 1,220 as the product of primes. And there's that word, primes. Prime numbers. So how do we do it? We make a tree. 1,220 is 10 times 122, right? Then 10 is 5 times 2, and 122 is 2 times 61. Now, your tree doesn't have to look, I mean, you could have started out your tree with 2 and 610. You follow me? You understand that? There's more than one way to build a tree, but when we're finished with the tree, this is what it's going to look like, all prime numbers. Is 61 a prime number? Do you have your prime number chart? I have mine. I mean, why go to the trouble of spending time with it? So that's another thing you want to put in your notes. Let me get my prime number chart out here. Your prime number chart. Bring that with you to the test so you can look at it and say, yep, 61's on there, so I don't spend time messing with it because it's going to be a lot of problems to work in the class time. Now, granted, when you take the test, you still have, when you come in here and take the test at, what, 8:30, 9:30, you have an hour and a half before chapel starts, so there's plenty of time to get the test done, but there's just a lot of work to do, so you want to keep moving. So, there it is. Now, here's my answer. Over here, I just rearranged them in order. And here, do you understand where all three of these say the same thing? And this is probably the way the answer book will write it because they think that's cute in mathematical circles. They dress it up. Questions? Problem 4. Write the prime numbers between 50 and 70. So you get your chart, your prime number chart, and you look at 50. It's not on there. Okay, what's the next prime number after 50? 53, then what? 59, then 61, then 67, and then the next one's beyond 70. Okay? Just bring your prime number chart with you, because there'll be a question like this on the test. Question 5. Is 143 prime or composite? Look at your chart. You go, what? Is that all there is to it? Well, if you didn't have the chart, you see how much time you could spend trying to figure it out? So just look at the chart. You've got it there. You can find them anywhere. I mean, even if when this class is over and you're out there in live someplace and you're going, hey, what's this thing about prime numbers? And all you have to do is go to the internet and just click prime number chart, and it'll give you one, and you're on your way to working with it. Okay. Number 6. Of the numbers 2,345, 436, 387, 1,530, which ones are divisible by 2? What's the rule for divisibility by 2? It's on page 223. Does anyone know the rule?
The numbers that add up together have to be divisible by 3.
That's for 3. That's the rule for 3. You add the numbers up and you add the digits and they're divisible by 3. Does anyone know the rule for 2? It ends in an even number. It'll tell you that on page 233. So write those rules down. So does 2,345 end in 2? Or an even number, I'm sorry? No. Does 436? Yes. So it's divisible by 2. Does 387? No. So it's not divisible by 2. Does 1,530? Is 0 an even number? Yes. So those are divisible by 2. What about 3? Now that's the one where we add up the digits. 2 and 3 and 4 and 5 add up to what? 14. Is 14 divisible by 3? No. So that number's not divisible by 3. 4 and 3 and 6. What's 4 and 3 and 6? 13. Is 13 divisible by 3? No. So that's not divisible. 1 and 5 and 3 and 0. 1 and 5 and 3 and 0. 9. Is 9 divisible by 3? So 1,530 is divisible by 3. You follow the process? Now what about divisible by 5? Who knows the rule for divisibility by 5? It ends in a 5 or a 0. So put that in your notes. It ends in a 5 or a 0. Okay, number 7. What does number 7 want me to do? Find the GCF. You know what GCF means, don't you? Greatest common factor. Okay, how do I find factors? Let's factor 254 first. I factored into 2 and 127. Then what do I do with 127? Because, did you look at your prime number chart? Is 127 on the prime number chart? Yes or no? Yes. So these are greatest common factors. So these are prime numbers. So I've got the product of primes. So I'm done with this one. Let's go up here and do 216. 216 I said was 3 and 72. That's 3 and 2 and 36. That's 3 and 2 and 6 and 6. 3 and 2 and 6 is 3 and 2 and 6 is 3 and 2. So there's the prime factorization. Now probably the book would show what? 2 to the what power? 3 to the third times 3 to the third. That just makes it look prettier. But now, with that information, what am I going to do? Because 7 says to reduce this fraction using these greatest, what's the greatest common factor? Okay, factors here are 2 and 127. Is there a 127 up here at the top? Is there a 2? So 2 is my greatest common factor. I look at the factors of each and say, what's common? Here's a 2, and here's a 2. Let me erase this one. So that means 2 is the greatest common factor. Then I use that to reduce it. So if I divide 216 by 2, I get 108. If I divide 254 by 2, I get 127. And that's the answer. That's reduced to lowest terms because I've factored out the greatest common factor for the two numbers. Number 8. Find the least common multiple, LCM. The least common, and I think on the test it'll say LCM and GCF. So you want to write down what those letters mean. The least common multiple. Now, if I were to write multiples of 18, that would be 18, and then what's the next one? 1 times 18 is 18, 2 times 18 is 36, 3 times 18 is what? 54. 4 times 18, 72. Dot, 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 dot. You see what I just keep going? And multiples of 54 would be 54. And then what? 108. No. What's 2 times? Yeah, 2 times 54 is 108. 3 times 54 is 162. Dot, dot, dot. And then I come down here and look at 60. And I start out with 60. And then 2 times 60 is 120. And 3 times 60 is 180. And I just keep going. And you see what would happen? I could list them all out here till I found the same number that appeared in both lists. And that would be the least common multiple. But I can use trees to find out what that number is. With 18, it comes out to be 2 times 3 times 3. With 54, it comes out to be 2 times 3 times 3 times 3. And with 60, it comes out to be 2 times 3 times 2 times 5. So if I want all 3 of these numbers to be in my box down here, let's just start over here on the right. I need a 5 in there. Everybody see that? And I need 2 2s and a 3. Does everyone see that? If this number is going to be a factor of this number in the box, I'm going to have 2 2s, a 3, and a 5 in it. Now, what does it have to have in the box to have 54 in it? A 2, which I already have one of those, and 3 3s. I already have 1 3, so what do I need to put in here? 2 more 3s. Now, let's go back to the first one. I need to have a 2, a 3, and a 3 in it. Do I have a 2? Yep, and a 3 and a 3. You follow me? I don't have to put any more in the box. Now, what is this number in the box? What's 3 times 3? 9. Times 3? 27 times 2? 54 times 10? 540. So do you understand the least common multiple? If I were to string all of these out, I would eventually get to 540. And if I strung these out, I would eventually get to 540. And if I strung these out, I would eventually get to 540. Let's just line them up above each other. So that's so cool. You follow what would happen? So you can use trees and get there faster, or you can just string them out till you find that common one out there. And it would take a while to get there, but that would work. Okay? Questions? Does 8 want me to do something else? Oh yeah, it wants me to add these fractions. So I come down here and I'm going to add 1/18 plus 1/54 minus 1/60. Well, look, 18 had 2 and 3 and 3 in it. So 18 has 2 and 3 and 3. So what's left? 3 and 2 and 5. What's 3 times 2 times 5? 30. So I take 30 times 1. And 30 times this produces this big denominator here. So 54. Let's come back up here and do 54. 54 was what? 2 times 3 times 3 times 3. So I have 3 times 3 times 3 times 2 is 54. So what's left? 10. So I take times 10 times 10. So that gives me 10 of these. 60 was 2 times 3 times 2 times 5. Here's 2 times 3 times 2 times 5. That's 60. So what's left? 3 times 3 is 9. So now I have 1 times 9, 9 of those. So now I take 30 plus 10, that would be 40. And 40 minus 9 would be 31 over 540. Can I reduce that down? Is 31 on your prime number chart? Then you can't reduce it down. See why you want to keep that chart handy? Questions? Number 9. A father left 1/4 of his estate to somebody, and then a half of it to somebody else, and an eighth of it to somebody else. So how much did he have to pay for taxes? Well, all I know is if you add all those together plus the taxes, you get one whole number, don't you? That would be the whole amount that he has to pay. Or that's the whole amount of his estate. So since it's 4 and 2 and 8, I get a common denominator, 8 and 8 and 8. 1/4 is 2/8, 1/2 is 4/8, 1/8 is 1/8, and then plus what? Would give me 8/8. 2 and 4 is 6, plus 1 is 7. So what do I need over here? 1/8. 7 plus 1 is 8/8. Everybody follow what happened? So I just found out what's the taxes? 1/8 of his estate. You see how I take all those words and just put mathematics stuff up here? Number 10. Change the following to equivalent addition problems. That means that 8 minus 19 is really 8 plus the opposite of 19. So that's 8 plus negative 19. What's the answer? Negative 11. Because after I do that, see, you say, why are you making me change these things? You say, I can just do it in my head. Okay, do it in your head. And then when you get your test back and it's checked wrong, then you can sit here in class and do it out in detail and get it right. I'm just telling you that doing these things in your head, you will make some mistakes. So 8 minus negative 19 is 8 plus what? Positive 19. And what's the answer? 27. Negative 8 minus 19 would be negative 8 plus what? Negative 19. And what would that be? Negative 27. You see where the answers look a little strange? Because if you were just doing it in your head, you would make a mistake. You go, well, I don't care what he says. I'm not going to make a mistake. Yeah, all right. It's your test on Monday. All I do is grade them. Here's negative 8 minus negative 19. What would that be? Negative 8 plus what? Positive 19. And what does that add up to be? 11. Any questions? Good. Let's go to problem 11. Evaluate. Now see, look what it gives me. It says evaluate all of this stuff. What are the rules for evaluation? What do you do first?
Paragraphs.
Page 252 is where you get the notes for that. Do the paragraph first. So, what's negative 6 plus 4? Negative 2. Then what do you do next? It should have times 10 to the 4th out here. Then what's the next thing we do after parentheses? Exponents. So now we have, looks like I already did this one, because you go from left to right. 4 times 12 is 48. Divided by 3 times 10 to the 3rd is 1,000 minus 2 times negative 2 times, let's change this, times 1 with 4 zeros. Okay? So now, what's 48 divided by 3? 16. Well, let's move this 16 over here a little bit. Oops, that didn't take. 16. Then times. Where did I get 10,000?
From 4 to the 10. Or 10 to the 4th.
16 times. That wouldn't be 10,000, would it?
Maybe 1,000.
That would be 1,000. Yeah. I don't know what I'm doing. So that, now that would come out to be 16,000, wouldn't it? And then this is negative 4 times 1,000 is negative 40,000. Not negative 4 times 10,000 is negative 40,000. But then minus a negative 40,000 would be what? Plus a positive 40,000. So the answer is 56,000. You see how you could do all this work up here, right, where I made my mistake, and then come down here and make a mistake in this subtraction part and get the wrong answer. And will he have that mistake as one of the choices on the test? Yes, he will. Yes, he will. Number 12, skip it. It's not on the test. So you don't need to do it for homework. This is a long enough assignment anyway. Number 13, reciprocals. Here's 2/3. 2/3 times its reciprocal equals 1. What would I take times 2/3 to get 1 for an answer? 3 over 2. Were somebody taught just to flip it over to make the reciprocal? Well, it's not exactly that, but that's close. So 3 over 2 is the reciprocal. For B, here's negative 4/7 times what would equal 1? Has to be a negative and then 7 over 4. And that's the reciprocal. That's called the reciprocal. Number C, 2 and 5/8, that's the same as 21 over 8, isn't it? 2 times 8 is 16 plus 5, 21 over 8. And then that's times what number? to get an answer of 1,
8 over 21.
and that's the reciprocal, 8 over 21. D, negative 8, that's negative 8 over 1 times what number would equal 1? And that's the reciprocal. You follow the process? Good. Questions? We're on our way. Number 14. Perform the indicated operation. Here the operation is multiplication. What's 7 times negative 5? So negative 35 over 8 times 16, 128. Can we reduce this down? Well, if I made a tree, 35 would be negative 5 and 7, wouldn't it? 128 would be, what, 4 and 32. And 32 would be 2 and 16, so I'm not going to get a 5 or a 7 out of 32. So you see where I've gone far enough to say, nope, that's my final answer right there. That's my final answer. Negative 35 over 128. 14b. Now, what are we doing now? Division. Does everyone remember how you divide with fractions? You don't. You take the fraction, negative 7 over 8, times the reciprocal, which would be negative 16 over 5. Everybody follow that? You change from division to multiplying by the reciprocal. And what does that equal? 7. Well, that would be, what's a negative times a negative? Positive. So I would have 7 times 8 times 2 over 8 times 5. Why did I rename 16 as 8 times 2? Why do you think I did that? Because I can cancel out the 8s, and the answer is 14 over 5. Everybody follow that? Good. Number 15, skip it. That's not on the test either. Number 16, calculate. So when this says calculate, these are scientific notation numbers. Do you remember how we calculate scientific notation? We take this number times this number and we get 48. Then we take this number times this number. And how do you multiply exponential numbers? You add 4 plus negative 6 comes out to be what? So that's 10 to the negative 2. But the book says put your answer in scientific notation. And 48 is not scientific notation, so I have to change 48 to 4.8 times 10 to the first. And then that's times 10 to the negative 2, and that becomes 4.8 times 10 to the what? 1 plus negative 2 would equal negative 1 for the exponent. You got that one? Good. Number 17. Perform the indicated operations. Oh, just get your calculator out and punch those numbers in with decimals and work them. Does anyone have a question about one of those? The first one you add them, the second subtract, the third you multiply, and the fourth you divide. So, let's see. You want to bring the practice test with you? You want to bring your prime number chart? You want to bring notes from what all this stuff means from the book? And then you want to bring a calculator. Probably ought to make a list when you have to remember to bring that many things to a test. Number 18. All right. It's going to get messy now. I'm going to make somebody mad here. Number 18 says, we measured the sides of a triangle and it came out to be these three numbers right here. Okay? So I write down those three numbers, and then what does it ask me to do for number 18? What's the perimeter? Does anyone know what perimeter means?
Add all the sides together.
It means the distance around the triangle, which means you add all those numbers together. So make sure you know what perimeter means, and if you don't, write the definition down in your notes. So now when you're finished, you just add those numbers up and there's your answer. And that will be one of the choices on the test, and if you pick that one, you will miss it. Because on the test, it will say correct. It'll say to the correct number of decimal places. Now, how do you determine how many decimal places to have in your answer? How many decimal places in this measure? I mean, how many places? How many significant digits in this number? 3. How many here? 3. How many here? 4. So how many in your answer? 3. So do we make it 4.45, 44.5, or do we make it 44.6? Because of the 8, we round this 5 up to 6. And can you believe on the test, it'll say to the correct number of decimal places, and then it will have this number as one of your choices, which will be wrong. It'll have 44.5 as a choice, which is wrong, because the correct answer is 44.6. Number 19. The dimensions of a college basketball court are 93.5 by 50.6. What's the area? Now, do you know how to calculate area? Do you know that? The length times the width. If you don't know that, put that down. Area is length times width. So you multiply these two numbers. And what do you get for an answer? 4,731.1. Except on the test, it's going to say to the correct number of decimal places. And how many significant digits here? 3. How many significant digits here? 3. So how many significant digits in my answer? 3. So the answer is 473 with a 0 for a placeholder. You got it? To the correct number of decimal places. Watch for that phrase. That's where you have to use the stuff about significant digits. And write down notes. Keep these sample problems with you so you can figure this out and get it right. Problem number 20. Write the following as a decimal. 3 over 4 is simply 3 divided by 4, which is 0.75. 1 over 15 is 1 divided by 15, which is 0.06 with a line over the 6, which means it just keeps going. On the test, if they put the answer like this, would you know that this and this mean the same thing? Do you know that those two things say the same thing? So if probably you would tend to do it like this, and then if you saw that on the answer, you would know that that is the same as what you have written down. Number 21. Write the following as the quotient of two integers. Okay, now because this test is going to be in a hurry, I'm going to show you a shortcut. And if it messes with you, don't worry about it. I'll show you the long way. But see this, where this 1, 2 repeats? Okay, if 2 digits repeat, that means I put the number 12, and what goes underneath? 99. Here's why. If I let n, let's change back to black. If I let n equal that number, and then I have 100n equals, well, let's erase this. That would be 12.12 with the line over it, or 12. And then down here I would have 0.12, 12. Then when I draw the line and subtract, I have 99n equals 12. So n equals 12 over 99. See what's going on? So you say, hey, if one thing repeats, if it said 0.6 with a line over it, that would be 6 over 9. If it said 0.725 with a line over all three, that would be 725 over 999. And I'm just showing you a little shortcut because when you start doing this work, it's going to take time, so I'm letting you see a quick way to get there. And I worked out B, but there's not one like B on the test. I want you to work it out. See, this is the kind where someone after class stayed and asked me about these kind where the numbers don't line up. Well, to make the numbers line up, I took the number times 100, and that gave me 265.555. Then I took the number times 10, and that gave me 26.555. Now the 5s are going to all cancel out. So I'm left with 100 minus 10 is 90n equals 239. So n is just 239 over 90. I don't think that was on the test. I mean, it doesn't hurt to write it down if you need to know how to do it, but I don't think that one's on the test. I glanced over it last night. I don't recall that being there, but since I worked it, maybe it would be good to have it in your notes. Okay, number 22. What do they want for 22? Write the following as decimals. Okay, do you know how to change a percent to a decimal? See, what this really says is this is really 21.0%. You follow that? There's no decimal point there, so if you put one there, it would be right there. And then to drop the percent sign, you just move it 2 places to the left, so it becomes 0.21. Here, to drop the percent sign, you move it 2 places to the left, becomes 0.0935. You follow the process? Here, to drop the percent sign, you move it 2 places to the left, 0.0026. Everybody see that? You could make fractions out of them, but we're at the place now where you're getting ready to take a test, and my impression is that you people prefer decimals to fractions. You're just not fond of fractions. I'm so sorry. I feel that's why I've befriended fractions. Nobody seems to like them. 23.
Dr. Bonet?
Yes?
The question about C, the fraction is 3 over 5, but I thought you divide the 3 by 5, which would get you a 0.6. So where does the 2 come from?
Which one?
C of 22.
Of 22?
Oh, never mind, I was looking down at the bottom.
There's a point, it's a 0.26% with a percent sign. And then I drop that and move it 2 places.
Yeah, never mind, I was looking at the other one.
Okay, 23. Now, I have to change this. They want me to add a percent sign. So what do I do to add the percent sign? Move it 2 places the other direction, and I get 52%. Move it 2 places, and I get 276.5%. 3/5, I divide 5 into 3, and I get 0.6. And then move it 2 places, and I get 60%. You follow the process? Number D. 2 over 11. Well, I divide 2 by 11 and I get this number here. So what do I do to change that to a percent? I just move it over 2 places and it becomes 18.111 ... percent. But look what it says in the instructions. And it'll say that on the test too. To 1 decimal place. Okay, here's 1 decimal place. Now, do I change it? See, what I have is 18.1818 ... percent. I change it to 1 decimal place. So do I leave it 18.1 or do I make it 18.2? Because this is an 8, so I have to round it up to 2. So there's your answer. Will they have 18.1 on the test as one of the choices? And will they have this big long thing as one of the choices too? Yes, they will. You've learned that by now, haven't you? You've done this long enough where you have now learned how to take a multiple choice math test. And no one's going to mess with you in the future now that you know how to do this. You know what's going to happen? You're going to be somewhere in life. I can just tell you this down the road. You're going to be somewhere in life taking a multiple choice math test when you go to grad school or something, and everybody around you is going to be all stressed out, and you're going to be sitting there smiling because you've learned how to take multiple choice math tests, and you can see on the test exactly what the guy's doing, and you'll chuckle a little bit, and the proctor will come by and say, there's nothing funny here. This is a graduate record exam. No chuckling. I'm going, sorry. And I look around, and all these people are stressed out. And I'm just telling you, now that you've learned how to take a multiple choice math test, you'll just sit there and smile and say, I've acquired a skill that these other people probably didn't have. Because no one taught them how to take the test. And that's pretty sad too, because the test doesn't reflect what you really know in math, because the guy who wrote the test is messing with you. But now your test will be a better reflection of what you really know in math. Okay, enough of that. Let's move on to 24. We got a test to take here. We can talk about that other stuff later. A 2-liter bottle of soda sells for 86 cents. There you go. And it cost 48 cents. So what do they know? What do they want to know? What was the profit? Fine. No, they want to know the percent of profit. What? Well, I know what the profit was, right? The profit was 38 cents. Everybody agree? But that's not what they're asking. And that'll be one of the choices on the test, by the way. But they didn't ask it. They said, what's the percent of profit? And how do I calculate the percent of profit? I take what I paid for it and put the profit on top and change that to a percent. And what's 38 divided by 48? Got your calculator there? 0.791666 ... So if I change that to a percent, I move it 2 places over, and it's 79.16%. And that'll probably be one of the answers too. But look what it says in the instructions. To 2 decimal places. So what do they want me to put for the answer? They want me to look at these 2 decimal places, and do I leave it 79.16 or do I make it, do I make it 79.16 or 79.17? Which one is it? Say, well, if I'm going to look at 2 decimal places and the next number, here's the decimal place, the next number is 6, I'm going to round that one up to a 7. So there's the correct answer. This one is wrong. And this one is wrong. Because this is what they want you to give them. Correct to 2 decimal places. No, this one's right. Sorry about that. That one's wrong and this one's correct here. Number 25. Man, we have really got a lot of stuff to cover here today. Number 25. About 4 million women make $25,000 to $50,000 a year. And this 4 million represents what? 15% of all the working women. See how they put numbers in there that have nothing to do with the question? So 4 equals 0.15 times of means times A, all the working women. So if 4 equals 0.15 times A, then if I divide both sides by 0.15, I get this new sentence. A equals 4 divided by 0.15. And what happens when you divide 4 by 0.15? You get 26.666 million women, working women. About, that's what it'll say on the test. About how many working women are there? Now, the answer book for your test, practice test, says 26.7. Okay, if they said there are 4 million, could there be 4,000,001? In other words, if they're rounding it off to the nearest million, then when it says about, your answer should be 26? No. What would it be? 27. Okay? Number 26. Classify the following as rational or irrational. Do you have your little chart of perfect square numbers? 2 is the square root of 4. 3 is the square root of 9. 4 is the square root of 16, and so on. You might want to make a chart and bring it with you, because see, when I look at this, I just automatically see it. What's the square root of 49? 7. That's why it's rational. What's the square root of 121? 11. Now I see that. Do you see that? If you don't have those perfect squares floating around in your head somewhere, write them on a sheet of paper and bring them with you. So that makes these two numbers rational. But this one in between here, radical 45 is really between what two rational numbers? Let's see. What's 8 times 8 is 7 times 7 is 49. Okay, there's 49, the square root of 49 on one side, and 6 times 6 is the square root of 36. So 45 is between radical 36 and radical 49, so that makes it irrational. You follow me? Because the two rational numbers are 6 and 7. D, why is that number rational? Because it repeats, and it has a repeating pattern. Repeats with a pattern. Actually, it repeats. No, it just repeats. Better not say that. It repeats. 2, 5, 2, 5, 2, 5, repeats. E, why is that irrational? It's got a pattern, but the pattern doesn't repeat. You see that? So it's an irrational number. Let's look at another one. What about this number here? There's no pattern, and it doesn't terminate. It repeats, so that makes it irrational. G, why is this rational? Because it terminates, so that makes this one rational. H, well, up here you said this was irrational, And down here you say this is rational. Why? Because it terminates. You follow what can happen? Question?
I don't see G and H on here.
No, you don't. I made them up.
Oh, okay.
Because I thought in this section it could be a little confusing. So I made some up to help you contrast them, to hopefully help you keep it straight in your minds. Number 27. Find a rational number between these two numbers. Well, what does that mean? 0.2 with a line over it is just the same as 0.222 ... And over here is 0.250. So I have 222 and 250. I have a whole bunch of things. I guess you could take 22 and 25 and say you have 0.023 and you have 0.024. You follow me? There's a whole bunch of things that you could find in between those that would be rational numbers. And the question about finding an irrational number, that's not on the test, so don't worry about it. So let's go to 28. What does 28 say? The diameter of a circular hamburger is 4 inches. So I drew a hamburger here and put the diameter in there. And what does 28 want to know? What's the circumference? The circumference of the hamburger. Well, do you all know this? The formula for circumference is pi times diameter. If you don't, write that in your notes and put down the formula for the circumference of a circle is pi times diameter. So you put the circumference equals pi, 3.14, times the diameter, 4, and you get 12.56. But on the test, it's going to say to the nearest tenth of an inch. So what would be the answer? 12.6. See how after you've done the formula right and get the answer, and will he have 12.56 as one of the choices? Yes. You say, and if I check that one because I just didn't read far enough, you're going to check it wrong? Yes. 29. 29 says the circumference of a basketball. So now we've got the circumference of the basketball, and we want to find the diameter. So the circumference is 29.5 equals 3.14 times the diameter. So the diameter would just be 29.5 divided by 3.14. What do you get when you divide 29.5 by 3. You go 29.5, hit division, 3.14, hit equals, what do you get? 3949044 ... Well, but look what it says. To the correct number of decimal places. Now when it says that, that's that significant digits thing. How many digits here? 3 significant digits here. How many digits here? 3 significant digits here. So how many digits do I want in my answer? 3 significant digits. And so I go 9.39. Do I leave it 9 or make it 9.40? And if that was a 5, I would make it 9.40. So read it carefully, because the guy who wrote the test is really trying to sneak up on you. Number 30, simplify. All that means is make a tree. And when you're through, you have the square root. I guess I should have finished this off. You have the square root of, the square root of 6 times, what's the square root of 16? 4. Look at your chart, your square root chart, and it'll show you. So the answer is 4 times the square root of 6. Over here, you make a table, 2 and 29, and those are both on your prime number chart. So you say, that's already simplified. There won't be one like that on the test. The one on the test you'll have to work. Number 31, another simplify. Now, Rationalize the denominator. That's what's wrong with this. It's got this radical denominator. So I take the top and the bottom times 20, the square root of 20, and I get 4 radical 20 over 20. Well, that makes this 5. And the square root of 20, I'm not finished, because I can break that down as to the square root of 4 times the square root of 5, which equals 2 times the square root of 5 over 5. There's my final answer. That's the one you want to check on the test. 48 over 49, that's too easy. I don't think that'll be on the test. 48 is just the square root of 3 times the square root of 16. 49 is 7. Square root of 49 is 7, so that's just 4 radical 3 over 7. Number 32. Multiply radical 8 times radical 6, and you get radical 48. And then simplify that to radical 16 times radical 3, and the answer is 4 radical 3. Divide. Well, before I divide here, I'm going to rationalize the denominator, just so I get that done early on. So now I have 56 is the same as square root of 4 times the square root of 14, and then the radical 7, and then underneath is just 7. Because 7 times 7 is the square root of 49, and the square root of 49 is 7. So now we've got, this becomes 2, and then 14 becomes the square root of 2 times the square root of 7. But I already had the square root of 7, so now I've got 2 times the square root of 7 times the square root of 7. That's the square root of 49, which is equal to 7, and that cancels this one out. So now I'm left with, these are gone, and now I'm left with 2 radical 2 for an answer. That was a fun problem. Number 33. You can't subtract until you simplify. So 9 times 10 is 90, and that becomes 3 radical 10. And 4 times 10 is 40, and that becomes 2 radical 10. And 3 of these minus 2 of these equals 1 of those. Number 33b. I'm going to add these 3. I'm going to add these 2 and subtract this one. So I have 16 and 2, 9 and 2, and 25 and 2. 4 radical 2 plus 3 radical 2 minus 5 radical 2 equals 7 minus 5, 2 radical 2. Number 34. What does C stand for? The hypotenuse. The hypotenuse equals the square root of a squared plus b squared. And it told me that one leg was what? 4. That's A, and that's B. 4 squared is 16. 6 squared is 36. 16 and 36 add up to 52. And 52 is the square root of 4 times the square root of 13, which is 2 radical 13. Skip 35. 36. Classify the following as arithmetic or geometric. Do you remember? Arithmetic is where we add or subtract something to go from one term to the next. What's geometric? You multiply. So how'd you get from 2 to 4 and from 4 to 8? Times 2 times 2. So what does that make this?
Geometric.
Geometric. How'd you get from 5 to 8 and 8 to 11 and 11 to 14? Add 3, add 3, add 3. So that makes that arithmetic. You follow that? Good. 37. Sum the first 10 terms. How many do they give you? 9, 13, 17, 21. So I just keep adding them. I mean, how did I get from 9 to 13? Plus 4, plus 4, plus 4. So I just add 4. Add 4, add 4, add 4. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. There's the 10th term, 45. That'll be one of the choices on the test. This guy's going to mess with you. But that's not what it's asking. It's not asking you. It's saying sum the first 10. And to do that, that means I have to go out to 10 places and then come back and take the calculator and go 45 plus 41 plus 37 plus 33 plus 29 plus 25 plus 21 plus 17 plus 13 plus 9 adds up to 270. Or you can use the formula. The sum of the first 10 terms is 10 times the first term, 9, plus the 10th term, 45, divided by 2. What's 9 plus 45? 54. What's 10 divided by 2? 5. What's 5 times 54? 270. So which way do you want to do it? A or B? Use the formula. You don't care? Hey, this would be a good way to check your work. Say, I'll do it both ways. And then if I make a mistake doing it one way, I'll catch my mistake doing it the other. What's the next one? We're done. Skip 38 through 40. See how long it took us to run through this practice test? I'm tired. So I'm sure some of you have a headache. So find some time over the break. Probably it would be good when you get back Sunday night or Monday before you come to class to take this practice test and walk through it before you walk in the room. Make sure you bring all of your equipment. Your prime number chart, your calculator, your copy of the practice test with the stuff worked out, and the notes from the stuff that you have to know about from the textbook. All right. Thank you for coming today. I've had so much fun.
Things you want to use yourself.